These are the frequently asked questions for Algebra 2, Section 4.4, Day 2, starting with number 38. And number 38 is 3x squared plus 31x plus 36. So we go through the steps that we talked about in class, where we try to see is their common monomial factor. Would love to get rid of that 3, but I can't because 3 will not divide evenly out of 31. So that means that this is one of the combination problems where we have to find the numbers in front that will give us first times first of 3x squared, and the numbers in the back that would give us combinations that multiply to positive 36 and somehow add to a positive 31. So I just go through the list. 1 obviously goes into 36, 2 obviously goes into 36, 3 goes into 36, 4 goes into 36, not 5, but 6 goes into it 6 times, 7, 8, 9, and then you realize you're repeating when you get to 9 because that would be 9 times 4. So now I need 31. So I start to think about combinations of numbers that I see here that might do that, and I'm thinking about 27 and 4. So I look at this combination right here and see, and remember your hand motions, outside times outside is 27, inside times inside is 4, and that adds to 31. So I remember that these both came from needing to be in the first position. So that's 3x and 1x. And these last two numbers came from having to be last times last to give us 36. And again, you always keep those in order as you have them, and you can certainly use FOIL on that to make sure that everything's going to work out the way that it should. Now, the next one that I had on the list here that I thought I would go through was number 50, and that's x squared plus 2x plus 1. And I know that seems really basic, but what I want to do is talk you through this in terms of what we should check whenever we're going to be factoring. So first thing I check for is common monomial factor. Nothing I can pull out of this. Then I check for those perfect squares. And this is a perfect square. It is x squared. And 1 is a perfect square. It is 1 squared. So what I'm going to do is I'm going to test that middle term and see if it fits the pattern. So I have to take x times 1, and then I have to multiply that by 2. And I do get 2x, which is the middle term right there. So that means I can write this as 1 binomial squared because it is a perfect square trinomial. And then you think, well, what did you square to get x squared? X. What did you square to get 1 in the back? 1. And then there's all pluses all the way through this, so that will be x plus 1 squared. Like I said, that's a really basic one, but I definitely wanted to go through that one with you just to show you that pattern that we get there. Then number 53 is 4z squared minus 20z plus 25. So again, I'm thinking common monomial factor here, but I can't take 4, I can't take a 2, it just isn't going to work out nicely. And then I notice this is 2z squared, and this is 5 squared. So I'm going to check that middle term to see if this is a perfect square trinomial. And I have 2z times 5, and that's going to give me 10z, and I have to multiply that by 2 to see if that will give me the middle term. And it will. It'll give me a 20z. So what I square to get 4z squared is 2z. What I square to get 25 is 5. But this one has a negative in the middle. So that means it has to be 2z minus 5, the quantity squared, for number 53. Then number 56 has x squared minus 4. And again, this is not a difficult problem, but I want to talk you through the process. First things first, common monomial factor. Nothing we can do there. There isn't anything that we can pull out. But then we notice this is a perfect square, and this is a perfect square. But there's no middle term. There isn't an x term for this. So it's in standard form should be ax squared plus bx plus c. So that means that b is 0. That's the reason it's not there. And as we talked about, the only way that's going to happen is if those signs are opposites of each other. So first times first had to be x times x to give us x squared. And then last times last had to be 2 times -2 to get us the -4. And we see, yep, inside times inside, outside times outside would cancel each other out. And we would get x squared minus 4. The next problem I thought you might ask for was number 60. And this one says the area in square centimeters of a square area rug. So I think about what squares have. They have 4 90-degree angles and 4 sides that are all the same. And it says the area of the whole thing is 25x squared minus 10x plus 1. And then it asks, what are the dimensions of the rug in terms of x? Well, here's what I know. For any square, the area of the square is something squared. And when I look at this problem, I realize, well, of course, this is a perfect square. This is a perfect square. This one must meet in the middle, so 5x times 1 is 5x times 2 does give me the 10x. So that means, again, that we had really one dimension, and it's the same dimension all the way around the square, and it had to be 5x in the front to multiply to give you the 25x squared, a 1 in the back to multiply to give you the positive 1, but this one needed to be 5x minus 1 squared. So when they ask for the dimensions in terms of x, it's 5x minus 1 by 5x minus 1, because it is a square. So that would be the dimensions that we would need. Then back to some good old factoring here, starting with number 61. And you're going to notice the directions have changed just a little bit here. It says factor each expression completely. That generally is a hint that we may have to do more than one form of factoring here. So first things first, I look for that common monomial factor, and I notice there is a 9 that could come out of both of those. And then as I'm writing it down, I'm thinking, hey, you know what? I just factored that on the last page. That's a difference of 2 square problems. That's x plus 2 and x minus 2. And so now I have it factored completely. There are no more squared terms, and there's nothing else that I can do with that. Number 63 says 12y squared minus 75. Now those are pretty big numbers, so that should tell us, yes, there's probably a common monomial factor here. And hopefully you noticed right away that 4 would work out really nicely. Now let's just say that 4 wasn't the biggest one. So when I got to this point, I would want to double check, is there anything else that divides evenly into 4 and 25? But it doesn't. But what I do notice about those two is that they are perfect squares. So there are only 2 terms. They are separated by a minus. That means the middle term dropped out because one was positive, one was negative. And 2y times 2y would be our perfect square of 4y squared. And then 5 and 5 would multiply to give us the 25 in the back. And again, we're done because we do not have any more squared terms that we could factor. Then number 73 is 4x squared minus 22x plus 10. And again, when I notice, hey, the numbers seem a little big here, that usually means there's some common monomial factor we can take out. I would like to take out the 4. I can't, but they are all even, so that means I can go ahead and take out the 2. Now the next thing I would look for is perfect squares. Unfortunately, I don't get those this time. I have a 2 in the front and I have a 5 in the back. So now I have to go to the combo method to try to find 2 numbers that multiply to 2 in the front, multiply to 5 in the back, but add to something that's negative, and that tells me they both have to be negative. So I'm looking for that outside times outside plus inside times inside to get me the negative 11. And that's right here. You're training your eyes again to do outside times outside is negative 10. Inside times inside is negative 1. So we're multiplying the 2 times the negative 5. And then we're multiplying the 1 times the negative 1. So I put my parentheses together by remembering that these are both from first positions, and then these two are both from last positions, because it had to be last times last that gave me that negative 5. Then number 73, after that, I wanted to go over one of the graphing ones for you. So let me take a peek at 108 with you. And 108 says graph each function. As I look at this one, I notice it's in standard form. So what I want to do is figure out, where is that vertex? So I have y equals x squared minus 2x minus 5. And if you want to, you can go ahead and write out what a, b, and c are with this. Doesn't make much difference as long as you can get to the vertex. So x equals negative b over 2a is our axis of symmetry. It's also the x coordinate of our vertex. So the negative of negative 2 is 2. And then we have a 1 value for a. So this is going to end up being x equals 1. That's our axis of symmetry. It's also the x coordinate of our vertex. So now I'm going to change gears, and I'm going to take that 1 and put it back into the original formula so that I can figure out where the x coordinate is. So doing the math, 1 squared is 1, 2 times 1 is 2, so 1 minus 2 is negative 1, minus 5 is negative 6. So our vertex is at 1, negative 6, and our axis of symmetry is at x equals 1. All right, so now, oh, you know what, I should grab graph paper. I don't want this to be all sloppy. So let me get out of here and get some graph paper to do this. All right, so back to the full screen. We're going to graph the axis of symmetry and the vertex. 1, 2, 3, 4, 5, 6, going by ones in each direction. Axis of symmetry. And then I just really need another point. I just need something else. And an easy one to do is always 0c. Well, our c value was negative 5. So that would take us right here. That's not enough, especially in a quiz or a test, that's just not enough. So what I'm going to want to do is put in at least one other number here. I've already used up 0, 1, and 2. Could certainly try 3 and see if that gives me a little bit of space here. So we plug that back in to the formula, and we get 3 squared minus 2 times 3 minus 5 is going to give us y. So y equals 9 minus 6 minus 5. 9 minus 6 is 3, and 3 minus 5 is negative 2. So 3, negative 2, use symmetry, equal but opposite on the other side, and that should do it. That should be good enough to give us an idea of what's going on with our parabola there. And there it is. So graph each function. I have all the important pieces of this recognized. While I'm here, I'm also going to go ahead and do the domain and range, even though they didn't ask for it. I know my domain is all reals, and my range is determined by the fact that this is going to open up, and that my y-coordinate of my vertex was negative 6. So y is greater than or equal to negative 6. That way I'd have everything covered if this were on a quiz or a test. That should do it for this section.